Hello everyone. Thank you for taking the time to watch this video. Myself, Raksha Agarwal, and I'll be giving a short presentation of our work titled Query-Focused Multi-Document Text Summarization using Fuzzy Inference at 8th International Symposium on Language and Knowledge Engineering. My co-author for the present work is Professor Naladri Chatterjee. Multi-document text summarization has assumed huge importance in modern times due to the exponential growth of electronic text in different domains. The task of multi-document text summarization is to create a gist of the contents present over several documents. This becomes even more challenging when the summary is to be made with respect to some specific user query. The summarization system in such a case needs to produce a summary that is not generic, rather one that is pertinent to the user query. The task involves dealing with ambiguities with respect to selection of the appropriate content from the collection of documents because similar sentences may exist in more than one document. Straightforward selection of all of them based on some important keywords may make the summary repetitive. In order to deal with this uncertainty, we propose a fuzzy rule-based inference system to achieve the intended goal. The present paper proposes a fuzzy inference system for query-focused multi-document text summarization. The overall scheme is based on a Mamdani Inferencing scheme, which helps in designing fuzzy rule base for inferencing about the decision variable from a set of antecedent variables. The antecedent variables chosen for the task are from linguistic and positional heuristics and similarity of the documents with the user-defined query. The decision variable in the present work is the rank of the input sentence as decided by the rules. The final summary is generated by solving an integer linear programming problem. For performance of abstractive summarization, coreference resolution is applied on the input sentences in the pre-processing step. Although designed on the basis of a small set of antecedent variables, the results are promising and outperforms various baseline systems. In the present work, given a set of documents and a user-specified query, constraint integer linear programming has been used to maximize an objective function designed on the basis of fuzzy rank of the sentences, text rank of the sentences, and key phrase code for the generation of summaries. Additionally, coreference resolution is employed as a pre-processing step for generation of abstractive summaries in addition to extractive ones. Calculation of similarity between different sentences or phrases are applied in various steps of the algorithm. The semantic similarity between different sentences or phrases are measured using cosine similarity between their embeddings. Text embeddings can be obtained by averaging the individual word embeddings, such as pre-trained glove or word-to-vec. Alternatively, a fixed size vector representation of the text can also be obtained by processing the entire text using transformer-based sentence BERT or universal sentence encoder architecture. In order to determine the best text vectorization scheme for measuring semantic similarity between text, the SIG dataset has been used in the present work. The SIG dataset contains 9,840 pairs of sentences annotated with a relatedness score between 1 to 5. A score of 1 indicates that the pair of sentences are least related, and 5 indicates that the sentences are extremely related. In order to assess different vectorization scheme, the correlation between the cosine similarity of the respective sentence vectors and relatedness score is studied. The results are presented in this table. Since vectors extracted using the pre-trained model ENSTSB Roberta Large have the highest correlation between cosine similarity and relatedness score, this has been used in the present work for vectorization of sentences and phrases. Next, we discuss the key phrase extraction scheme. Key phrases are the words or phrases that represent important topics mentioned in the given text. These can be 1 to 10 words long. A sentence containing multiple important key phrases will have a stronger candidature in the summary. From a given set of sentences, key phrases along with its respective score is extracted using rapid automatic keyword extraction or rake. The score of each key phrase is the sum of individual word scores calculated using a graph of word coreferences. Next, we discuss the fuzzy logic-based ranking. Fuzzy ranking has been performed using Mamdani fuzzy inference system. The proposed inference system incorporates 5 different antecedent variables along with manually defined rules to derive a crisp value for the consequent variable rank. The crisp inputs corresponding to the antecedent variables are fuzzified using triangular fuzzy numbers. For defuzzification of consequent variable, mean of maxima is employed in the present work. Experiments with centroid or center of gravity defuzzification strategy yielded inferior results. Next, we discuss the antecedent variables used in the fuzzy ranking procedure. Before defining the antecedent variable, we present some notations. The source sentences are denoted as S1 up to Sn. The source key phrases are denoted as small sk1 up to skr. Query title is denoted by Qt. Query description sentences are denoted by QD1 up to QDM, and query key phrases are denoted by QK1 up to QK2. The first crisp input or antecedent variable is QTitleSim. The QTitleSim represents the similarity between the source sentence and the query title. The second antecedent variable is QDescriptionSim. QDescriptionSim represents the maximum of the similarity between the source sentences and each query description sentence. The third antecedent variable is KeyScore-Ki. It represents the sum of scores of the key phrases present in the source sentences. To incorporate query relevance in the key phrases, a subset of SK is derived on the basis of similarity with query key phrases. Each key phrase SKJ in SK is assigned a query similarity score, which is calculated as maximum of similarity of SKJ with the query key phrases. Top n k phrases based on the query similarity score is collected in a set called SK subscript n. Key score of SI or sentence I is calculated as a sum of weights of the key phrases belonging to SKN, which are also present in SI. The last two antecedent variables are rel pos and length. Rel pos represents the relative position of the source sentence in the respective source document. Suppose SI belongs to a document D such that the total number of sentences in D is M subscript D and SI is at the mth position, then the rel pos of SI is defined as M upon MD. Length of sentence I is represented as Li, which is the number of words in SI. A triangular membership function is used for fuzzification of the crisp values of the antecedent variables. A triangular membership function is characterized by three parameters A, B, and C such that A and C denote the feet of the triangle and B denotes the peak of the triangle. In this table, the linguistic terms for antecedent variables and consequent variables along with their respective parameters are described. It can be observed that the parameters for the antecedent variables are not static. This enables the inference system to adjust the linguistic terms for different set of antecedent variable values as per corresponding to different input document sets. The process of designing rules is an important part of any fuzzy inference engine. In the present work, if-then rules have been built manually using human knowledge. A set of 67 rules were finalized by two experts. A few examples of the rules have been presented in this table. The fuzzy ranking step measures the importance of sentence based on its relevance to the query, presence of key phrases, position, and length. The importance of the sentences may also be analyzed using text rank. Text rank is a graph-based ranking algorithm where vertices represent sentences and weighted edges are formed by connecting sentences by a similarity matrix. Text rank determines the importance of each vertex based on global information extracted recursively from the entire graph. The rank of each vertex is initialized as 1 and updated as described in the equation. Here, D is the dampening factor, which is set to 0.8. In a multi-document setting, many similar sentences conveying the same information may be present in the source text. Selection of multiple similar sentences in the summary leads to redundancy. Therefore, sentence clustering is aimed at grouping similar sentences. Selection of at most one sentence from each clusters help to decrease redundancy in the summary. Moreover, selection of sentences from diverse clusters increases the information coverage in the present work. Hierarchical agglomerative clustering with complete linkage criterion is used for clustering. Clusters with similarity above a threshold lambda are merged together. The summary generation has been performed using an constrained integer linear programming problem. The summary is generated by selecting the most important sentences relevant to the query while avoiding redundancy or selection of similar sentences. The sentence selection problem is formulated as a concept-based integer linear programming problem. Here, small si represents the presence of sentence si in the summary. Tri represents the text rank of the sentence si. Fri represents the fuzzy rank of the sentence si. Small skj represents the presence of key phrase skj in the summary. Prij represents presence of key phrase skj in the sentence si. Prij is 1 if skj belongs to sentence si, otherwise it is 0. The objective function of the ILP problem aims at selecting a subset of sentences in order to maximize the text rank, the fuzzy logic based rank, and presence of important key phrases in the summary. The first constraint ensures that the sentence selected in the summary contains at least L words. The second constraint limits the summary length to W words. Here W is set to 250. The third constraint prevents redundancy in the summary by allowing only one sentence per cluster. The fourth constraint ensures that if a sentence is selected, then all the key phrases present in it are also included in the summary. The fifth constraint ensures that if a key phrase is selected, then at least one sentence containing the key phrase is also selected in the summary. The constraints 4 and 5 ensures compatibility between the selection of key phrases and the sentences. Next, we discuss the coreference resolution scheme. In the present work, the sentences of the input source are ranked individually without taking into consideration its context. This leads to poor ranks for sentences having many coreferent terms. For illustration, consider the sentence, "It outlaws smoking in public and the workplace." The presence of pronoun "it" makes the sentence unsuitable for inclusion in the summary in spite of the presence of important information. The coreference resolution performed using the context of this sentence is a drastic anti-smoking bill outlaws smoking in public and workplace. A pre-processing step of coreference resolution has been applied in the present work. It replaces pronouns by its coreferent head, which enables each sentence to be capable of communicating its relevant context by itself. The summary thus generated is of abstractive form because the source sentences are modified using coreference resolution. In the present work, we have used UC 2006 dataset, which contains 50 document sets along with 4 manually written summaries, and every document set contains a user-specified query which contains query title and 1 or more description sentences. Mean recall values of RUJ 1, 2, and SU4 are reported in this table of the proposed system along with NIST baseline and ERSS system. The NIST baseline corresponds to selection of lead sentences of the input document in the summary, and ERSS generates query-focused multi-document summaries using fuzzy coreference cluster graphs. It can be observed that for both extractive and abstractive summarization strategies, the proposed system outperforms the NIST baseline by a significant margin. The proposed system also outperforms the ERSS system in terms of RUJ 2 and RUJ SU4, while RUJ 1 scores are competent. The efficacy of individual components of the proposed system are also studied for extractive and abstractive summary generation. In these tables, the top rank selection strategy refers to selection of top ranking sentences in the summary such that the total number of words is less than 250. Similarly, 1 per cluster refers to selection of sentences such that the sum of ranks of the summary sentences is maximized while selecting at most 1 sentence per sentence cluster. ILP refers to sentence selection process using integer linear programming as discussed before, but here the objective function contains only 1 sentence ranking term. The summaries generated using fuzzy rank outperforms text rank across all selection strategies. Additionally, it can also be observed that the ILP selection strategy emerged superior to other selection strategies. We can observe that the scores for extraction is marginally higher than abstraction for all the summarization methods. In order to analyze the importance of individual antecedent variables, ablation test was performed. Summaries were generated using the proposed method by removing 1 antecedent variable at a time. The values of different evaluation strategies for extractive and abstractive summaries are reported in these tables. It can be observed that for all the evaluation matrix except blue, removal of each antecedent variable decreases the system score. This indicates that each variable has a positive contribution towards the final performance of the summary. Title sim, Q description sim, and key score leads to higher decrease in the score than rel pos and length. Q-title sim emerged as the most important variable for both extractive and abstractive summarization, as its removal led to the highest decrease in score. It can also be noticed that with respect to root scores and CIDR, the importance of key score is higher than Q description sim for extractive summarization, while it is the opposite for abstractive summarization. Blue metric, the highest value is obtained upon removal of Q description sim. The suboptimality of blue score, which is a precision-based metric, may be attributed to the fact that the parameter values ln and lambda have been selected on the basis of highest root scores, which are based on recall values. However, removal of all the other variables decreases the blue score of the system. Furthermore, it can be observed that for metrics based on lexical overlap, which are rouge, blue, meteor, and CIDR, the abstractive summaries have lower values than extractive summaries. In contrast to that, with respect to vector similarity metrics, VEX and BIRD score, abstractive summaries have higher values than corresponding extractive ones. The present work proposes a query-focused multi-document summarization scheme. Mamdani fuzzy inference with manually defined rules have been applied to rank the sentences on the basis of a small pool of 5 features. The features represent properties of the sentence such as query relevance, position, and length. The summary is generated by solving a constrained ILP problem where the objective function aims at maximizing the fuzzy logic-based rank, text rank, and presence of important key phrases in the summary. A constraint of the ILP problem allows the selection of at most one sentence per cluster to reduce the redundancy in the summary. Coreference resolution of the input sentences is performed for generation of abstractive summaries. While the proposed system outperforms baseline systems, fuzzy ranking also outperforms graph-based text rank scheme for different sentence selection methods. It was observed that the extractive summaries have higher scores than abstractive summaries, which indicates that replacement of pronouns increases the informativeness of a sentence at the cost of higher length and repetition of words. In future, we would like to perform selective replacement of pronouns along with other abstractive techniques such as lexical paraphrasing of complex words, sentence compression, and fusion. We would also like to extend the current set of features used in the fuzzy ranking scheme to incorporate other aspects of the document such as cohesion, readability, and discourse analysis. The references used for the present work are as follows. Thank you very much for listening to this presentation.